Imagine this scenario, right? You finally moved into that gleaming, state-of-the-art building.
Right.
The one you poured your heart and, let's be honest, a significant budget into. On paper, it was just a marvel. The architectural renderings were stunning. The design promised peak performance, comfort, efficiency, all the good stuff.
A dream project.
Exactly. But then reality hits. Suddenly, some parts of the building are, like, inexplicably sweltering hot while other areas are freezing cold.
Oh, yeah, I've heard this story before.
And your energy bills, astronomical, despite all those supposed high-tech energy-saving features.
Right, the ones that were supposed to save you money.
And that advanced HVAC system, the heating, ventilation, air conditioning, it seems to have a mind of its own, constantly battling itself, failing, or just plain misbehaving.
Yeah, not working as a cohesive system.
It's this brilliant vision on paper, but the lived-in reality. It's just a costly, uncomfortable, and frankly, frustrating nightmare.
So the big question is, how do we make sure a building actually performs as intended? Not just in the blueprints, but in the real occupied world.
That's the million-dollar question, isn't it?
Welcome, everyone, to the Deep Dive. Today, we're plunging into a really critical quality assurance process that bridges exactly that gap, the gap between architectural vision and operational reality. We're talking about building commissioning. Our mission in this deep dive is basically to unpack this essential, though maybe often overlooked, practice. We'll trace its surprising origins, dissect its meticulous, phased process, and ultimately reveal the immense value it delivers to you. Whether you're a future building owner staring down a huge investment, maybe a project manager navigating complex construction, or just someone, really curious about how our built environment truly comes to life and, crucially, how it works. And that framing is perfect because that age-old problem you just described where a building's brilliant design doesn't quite translate into its intended performance well, that's a significant and very costly issue in construction.
Right.
Commissioning, in essence, it's this systematic, rigorous process. It's about verifying and documenting that all of a building's incredibly complex systems, and we're talking everything, HVAC, life safety, plumbing, electrical, even the building envelope itself.
The whole shebang.
The whole thing. That they're meticulously planned, designed, installed, tested, and can be operated and maintained precisely according to the owner's specific requirements.
Okay.
It's really a comprehensive, proactive approach to quality. It's designed to catch problems before they become catastrophes.
That really drives home the difference in scope, doesn't it? Compared to just, say, a final inspection or a punch list.
Absolutely. Night and day, really.
And to guide us through this pretty intricate landscape, we'll be drawing insights from some fantastic sources today. We've got a guide to the project management body of knowledge, the PMBO Guide.
A classic.
The CMAA Construction Management Standards of Practice, the BIM Handbook.
Very relevant with modern tech.
And we'll even take this fascinating detour into the engineering prowess of Isambard Kingdom Brunel, just to understand the historical roots, rigorous system verification.
Yeah, that connection is actually quite illuminating.
Okay, let's unpack this.
Let's do it.
So here's where it gets really interesting, I think. To truly grasp the essence of modern building commissioning, we actually need to look beyond buildings for just a moment.
Okay.
We're going to journey back in time to the naval industry, specifically to the era of pioneering engineers like Isambard Kingdom Brunel.
Ah, Brunel. Right.
You see, back then with these massive, complex machines like ocean liners, it was simply, unthinkable to launch a ship without rigorously testing all its systems first.
Stakes are just too high.
Exactly. The stakes weren't just high, they were, existential. A failure could mean catastrophic loss. Lives, cargo, the whole ship.
And what's fascinating there is the sheer foresight, the parallel in mindset, really. Brunel, who is a true visionary engineer, he exemplifies this perfectly.
How so?
Well, when his colossal iron ship, the Great Eastern, was getting ready for its maiden voyage, he dictated this meticulous, I think it was a 2-page list of matters to Captain Claxton.
2 pages, wow.
Yeah, and this wasn't just some casual checklist, It was a detailed set of instructions, a systematic plan, basically, to ensure every single aspect of the ship's operation was thoroughly considered, verified, and ready.
So real systematic thinking.
Absolutely. And get this, he was apparently overseeing all this operational readiness from his sickbed, which just highlights the absolute critical importance he placed on comprehensive testing. He wouldn't let it go.
And it paid off, right? I mean, the launch.
It paid off in spades. Yeah. Despite some initial delays, bad weather, challenging conditions, The usual stuff, the actual launch operation went, and I quote, remarkably smoothly.
Remarkable.
And contemporary accounts noted this was a direct tribute to the foresight of the engineer and the accuracy of his calculations.
That's incredible. Think about the precision involved there.
Exactly. Requiring specific maneuvering to avoid fouling the massive paddle wheels. He even ordered a barge to be scuttled, just sunk, to clear an obstruction.
No way. Just get it out of the way.
Yeah. These weren't minor details. They were critical steps that were anticipated, planned for, and executed to ensure the entire complex system worked exactly as it should, without a hitch.
Because the stakes in launching a ship were just immense. Potential loss of life, cargo, financial ruin if systems failed.
And if we connect that back, right, those high stakes on a ship translate directly to modern buildings. Maybe not always life or death in the same immediate way, but
Still significant consequences.
definitely. A building system failure, whether it's HVAC, fire suppression, structural integrity, it can lead to significant occupant discomfort, sky-high operational costs, safety hazards, even long-term structural problems.
So that meticulous, almost obsessive pre-launch verification that Brunel insisted upon, that's kind of the conceptual ancestor of building commissioning.
Precisely. It's about ensuring that the complex machine, whether it's a ship or a skyscraper, performs reliably, safely, and efficiently right from the outset. No nasty surprises on day one.
That's a perfect segue, actually, to how this tradition evolved. From these grand ships to the towering skyscrapers and sprawling campuses we build today, addressing what we call the building performance gap.
That gap is real.
Modern buildings are they're incredibly complex beasts, aren't they? Far more than just structures. They're intricate systems of systems.
Absolutely. Mechanical, electrical, plumbing, MEP, life safety, structural, architectural elements, they're all intertwined. They're all expected to work together seamlessly.
And the details matter. I was looking at the Builder's Guide to Hot, Dry, and Mixed Dry Climates, and it points out really granular things like air handling units, the potential for ductwork leakage,
Oh, duct leakage is huge.
and the critical role of vapor management in roof and wall assemblies. It just underscores how many distinct, interconnected components need precise coordination.
They really do. And that inherent complexity highlights this persistent and costly problem. The disconnect between design intent and actual performance.
Right. The gap.
Yeah. A design might look perfect on blueprints, or even in a sophisticated 3D building information model, a BIM model.
Which are amazing tools.
They are. But executing it in the real world with all the human variables, material tolerances, unforeseen site conditions, that can introduce significant discrepancies.
So how do we make sure what's meticulously envisioned in the design actually materializes and performs like it's supposed to, consistently?
Well, that's where things like BIM itself and commissioning working with BIM come in. The BIM handbook notes that BIM has become a catalyst for significant process and contractual changes to address this very issue.
How does it help?
Well, BIM can facilitate a distributed team to work simultaneously on a project in real time. So architects, engineers, builders, they can all see and interact with the same digital model.
Ah, okay. So everyone's on the same page, literally.
Exactly. And this allows for pre-construction discovery of omissions, like, a pipe clashing with a structural beam, which you'd never see on separate 2D drawings easily.
Right, until it's too late.
Precisely. And it aids in procurement construction synchronization. Catching these issues digitally saves immense time and money compared to finding them during physical construction.
Absolutely crucial. And this brings us to that common misconception we touched on. Commissioning versus the good old punch list.
Ah, yes, the punch list confusion.
Many people, maybe understandably, they confuse the two. They think they're essentially the same thing. I mean, the CMAA Construction Management Standards of Practice mentions punch list items as part of the final payment process.
Right, end of the job stuff.
Yeah, suggesting it's typically a closeout activity, a final tidy-up. But the distinction is vital, isn't it? Understanding it is key to grasping commissioning's real value.
It's fundamentally different in scope. It's like comparing, checking if all the instruments are in the orchestra pit versus making sure the entire orchestra is playing a flawless symphony together.
Okay, I like that analogy.
A punch list typically focuses on identifying static, cosmetic, or incomplete items. Think a missing light fixture, a paint scratch on a wall, a door that doesn't quite latch.
Stuff you can see, basically. Static things.
Exactly. It's about checking off items that are physically present and look okay. Commissioning, however, zeroes in on dynamic system performance.
Dynamic performance. Okay, what does that mean in practice?
It's not just asking, is the HVAC unit installed? It's asking, does it actually heat and cool efficiently, precisely to the specified temperatures, under varying loads, varying occupancy levels? Are its controls optimized for peak energy performance?
Gotcha. How it works, not just if it's there.
Precisely.
Right.
It's about ensuring fire alarms trigger correctly and initiate the proper sequence of events, shutting down air handlers, unlocking necessary doors, not just that they beep when you press the test button.
Right, the whole system response.
Yes. It's about verifying that all these disparate systems interact as a cohesive whole to meet the owner's operational goals and performance metrics. It goes way beyond mere physical presence.
So what, for you, the listener, is really immense here, isn't it? Why should you care about this distinction?
Well, think about it. A beautifully designed building that doesn't function like it's supposed to, that's a massive ongoing headache, and it can cost a fortune.
Like that magnificent ship that looks great but won't sail right.
Exactly. A poorly performing building drains your budget with excessive energy costs, demands constant, expensive maintenance calls, and significantly impacts occupant comfort, health, and productivity.
Which hits the bottom line, too, eventually.
Absolutely. Commissioning is the proactive, preventative step to avoid that costly, frustrating nightmare. It ensures the building delivers on its promises, performing not just tolerably but optimally for its entire lifespan.
Okay, so now that we've established just how critical this is, let's dive into defining commissioning itself. What is this core of quality assurance?
At its heart, it's about systematic verification and documentation. The CMAA, Construction Management Standards of Practice, gives us a good framework. It defines quality assurance, or QA, as, let me get the wording right, all those planned and systematic actions necessary to provide adequate confidence that a product or service will satisfy given requirements for quality.
Okay, planned and systematic actions.
Right. And commissioning is basically the comprehensive application of that QA principle across the entire building project lifecycle, ensuring everything aligns with explicit, predefined quality and performance requirements.
And you mentioned it goes beyond just meeting minimum building codes.
Oh, absolutely. That's a crucial point. Building codes are often the legal baseline, the minimum standard.
Yeah.
You look at something like Building Codes Illustrated, it outlines requirements for basic safety, structural integrity, things like allowable building height, fire-rated fire partitions, minimum flame spread ratings for interior trim.
Must-haves.
Exactly.
Yeah.
Crucial, non-negotiable baselines every building must meet. But commissioning steps well beyond mere compliance. It aims for optimized performance.
Optimization, okay.
It's about ensuring a building not only meets the code, but also achieves the owner's higher aspirations. Things like peak energy efficiency, superior indoor air quality, specific operational resilience goals, things that often exceed what codes mandate.
That's a key distinction, creating real value then. Give me an example.
Sure. So, Sustainable Construction Green Building Design and Delivery talks about setting water consumption goals that significantly exceed code requirements.
Yeah.
Maybe aiming for a factor 4 reduction through strategies like recycling gray water or installing high-efficiency, low-flow fixtures.
Right, going above and beyond.
Exactly. Commissioning aims to verify those higher performance goals. It's about making sure those low-flow fixtures are actually installed correctly and delivering the promised water savings. Or that the high-performance glazing specified for the windows is actually providing its specified R value, its thermal resistance, and its solar heat gain coefficient, blocking unwanted heat.
So making sure the intent translates into actual performance.
You got it. That's the essence.
And you mentioned the owner's requirements being central to this.
Absolutely. At the absolute core of this optimization, really, the entire commissioning process is the owner's project requirements, or OPR.
OPR.
This isn't just some casual wish list. It's the foundational document. It's the guiding star for the entire project. Now, it might not always be explicitly labeled OPR in every single source or contract.
Right.
But the concept is there. The CMAA Construction Management Standards of Practice, for instance, describes the Project Management Plan, or PMP, as defining the project requirements. And that includes scope, budget, schedule, environmental conditions, and the basic systems to be utilized.
So that's where the owner's vision for performance gets captured?
Precisely. What they expect the building to do, how it should operate, and the specific performance metrics it must achieve. It needs to be formalized, measurable.
Which means planning up front, really early on.
Yes. Proactive planning. The BIM handbook reinforces this. It points out that these performance-based contracts often require that the owners spend more time early in the project to define the facility requirements and structure the contracts to match.
So more work for the owner up front.
A bit more, maybe, but it's critical engagement. It solidifies that OPR giving every single person on the project, team, architects, engineers, contractors, a clear, measurable target for performance. It shifts the focus from just what it looks like to how it functions and how well it meets the owner's long-term business and operational goals.
Okay, that makes sense. Now, can you clarify the roles? You mentioned quality assurance, QA. Is there also quality control, QC?
Good question. Yes, and the distinction is important. The CMAA, Construction Management Standards of Practice, helps here. It distinguishes between quality control, QC, and quality assurance, QA.
Okay.
QC refers to the operational techniques and activities that are used to fulfill requirements for quality. Think of these as the checks and balances performed by the contractors themselves during construction.
Like a plumber testing their own pipe connections for leaks.
Exactly that. That's QC. QA, on the other hand, is the overarching, the planned and systematic actions necessary to provide adequate confidence that a product or service will satisfy given requirements for quality.
So QA is more like the oversight, the verification that QC happened and was effective.
You've nailed it. QA is the independent verification that the QC efforts were effective and that the final product truly meets those specified requirements, the OPR.
So this is where the project manager, the PM, and ultimately an independent commissioning agent come in.
Precisely. The PM, according to the CMAA, monitors and provides oversight during the design process and works with the construction manager, the CM, to assure quality during the construction process. That sets the stage perfectly for a dedicated commissioning agent.
And they provide that independent QA.
Yes, that independent third-party quality assurance. They aren't just double-checking the contractor's work, which is QC. They're verifying that the contractor's own quality control measures were effective and that the final integrated systems truly meet those predefined owner's project requirements.
Gotcha. It's that essential layer of objective scrutiny, making sure the owner's performance goals are always front and center.
Exactly right.
Okay, so if commissioning is this vital QA process, what does it actually look like in practice? You said it's not just a final inspection.
Definitely not. It's not a single event at all. It's a continuous, systematic journey that spans the entire building life cycle.
The whole life cycle.
Yeah. The CMAA, Construction Management Standards of Practice, logically breaks down typical project phases.
Yeah.
Pre-design, design, procurement, construction, and post-construction.
The usual phases.
Right. And crucially, commissioning isn't bolted on at the end. It's integrated into all of these phases. It ensures a continuous, vigilant focus on performance from the very first conceptual sketches all the way through to the building's operational handover.
Okay, let's walk through that, starting with pre-design.
Right, the pre-design phase. This is really where the foundation of performance is laid. You develop the project management plan, the PMP, like CMA outlines. The CM works closely with the owner, the design professional, to agree on the overall goals of the project with respect to time, the schedule, and establish the scope, budget, schedule, environmental conditions, and the basic systems to be utilized.
And this is where that OPR gets formally defined.
Exactly. This is the critical stage where the owner's vision for functionality and performance is first articulated in that pivotal owner's project requirements document. We're talking specifics like the building must achieve LEED Gold certification, or the HVAC system must maintain temperature within plus or minus 2 degrees and 5% relative humidity year-round.
Measurable goals.
Measurable, verifiable goals. Maybe the building's energy consumption must be 30% below the ASHRAE 90.1 baseline. These aren't just vague aspirations. They become the concrete targets that commissioning will verify later on.
And for today's projects, especially with digital tools, you mentioned BIM.
Yes, building information modeling. CMAA standards emphasize establishing clear BIM goals and objectives with the owner during this pre-design phase. It involves educating the owner on the BIM process, defining the BIM scope of work.
Why is that important so early?
Because it ensures the digital model is developed with the desired performance outcomes in mind right from the start. And this early integration, as the BIM handbook highlights, can lead to that pre-construction discovery of omissions.
Finding problems early.
Yes, identifying clashes between systems, design inefficiencies, missing components, long before physical construction begins. Imagine catching a critical design flaw, maybe a misaligned duct system that would cost a fortune in rework and waste energy for decades, finding that when it's just pixels on a screen, not concrete and steel.
That's huge. Way cheaper to fix digitally.
Exponentially cheaper. It avoids those nightmare rework scenarios.
Okay, so that's pre-design. What happens in the design phase?
All right, design phase. This is where the owner's vision from the OPR starts getting translated into actual plans and specifications. The commissioning agent becomes really active here, working with the design team, architects, engineers, structural MEP.
Integrated design.
Exactly. The BIM handbook emphasizes BIM's role here as a multidisciplinary design, analysis, construction, and facilities management technology. The commissioning agent acts as an independent reviewer.
What are they reviewing?
They're scrutinizing the plans for commissionability. Basically, can the system actually be tested effectively? Are there adequate access points for maintenance and testing later? Are the control sequences clearly defined and logical?
Makes sense. You need to be able to test it.
Right. They participate in design reviews, flagging potential conflicts between systems, ensuring that everything from the type of window glazing specified to the fan coils chosen is not just architecturally pleasing, but functionally sound, verifiable, and optimized for those performance goals in the OPR.
So they're checking performance specs too, like
Yeah.
R values.
Absolutely. Reviewing R values, solar heat gain coefficients for windows, coefficient of performance for chillers, the specific control logic for variable air volume VAV boxes, all those details that dictate actual performance.
And this probably needs to be reflected in contracts too.
Definitely. Smart contractual language is key. CMAA recommends appropriate language in the design team contracts about the use of BIM and the availability of the model to other project team members.
Why is that language so important?
Because it ensures that the rich information within the BIM model performance specs, system layouts, is accessible to the commissioning agent and the construction team. It allows for better coordination, earlier detection of issues, and more accurate verification against the OPR later. It transforms the model from just a pretty picture into a living database for performance.
Gotcha. And it goes down to specific components, right?
Oh, yeah. Very granular detail in this phase. Component specification is crucial. Think about the sheer number of parts. Rigid insulation, sealant, adhesive, or gasket mentioned in the builder's guide, to fire-rated structural elements like bearing walls and the structural frame outlined in Building Construction Illustrated. The design phase ensures these components are specified not just for their individual properties like this type of pipe, but for how they contribute to overall system performance.
So how they work together.
Exactly. Selecting materials that will work together to create, say, an airtight building envelope or an efficient HVAC distribution system that minimizes pressure drops or a fire suppression system that integrates seamlessly with emergency power. It's all about the integrated system.
Okay, design phase covered. Next up, procurement phase. Getting the stuff and the people.
That's it. Procurement is where paper plans start turning into physical components and skilled labor arriving on site. And the commissioning thinking continues here.
How so?
Well, in certain contracts, like guaranteed maximum price, GMP agreements, project management in construction notes that the final selection of subcontractors may be subject to approval by the owner.
So the owner gets a say.
Right. And this is a critical point where the commissioning plan can heavily influence those choices. You push for subcontractors and suppliers who have a proven track record in delivering quality, who understand the performance objectives, and who can meet the rigorous installation and testing requirements outlined by the commissioning agent.
So it's not just about the lowest bid.
Definitely not. It's about the best value for long-term performance. You want people who get it.
And making sure those requirements flow down.
Absolutely critical. Maintaining that chain of responsibility. Subcontract agreements often include what are called pass-through provisions. Project management in construction mentions these bind subcontractors to the contractor by the terms of the contract documents and make them assume the same obligations the contractor has towards the owner.
So everyone's on the hook for commissioning requirements.
Pretty much. It ensures those detailed commissioning requirements and performance goals set initially by the owner in the OPR flow down the chain, from the GC to every sub and supplier. It creates a unified commitment to quality, ensuring everyone's working towards the same verifiable performance targets.
Okay, now we get to the really gritty part,
Uh,
the construction phase, building it right.
this is where the rubber meets the road, yeah.
Yeah.
Pipes going in, wires being pulled, walls going up, and commissioning is very active here.
What's the focus?
Verification and testing. CMAA standards emphasize that inspection and testing consistent with the Project Commissioning Plan, PCP, should be verified. through inspection of the contractor's work, preferably on a daily basis.
Daily inspection.
Preferably, yes. It's not just spot checking at the end. It's a continuous, vigilant process of verification, ensuring installations adhere strictly to the design documents and the commissionability requirements we talked about. This involves reviewing manufacturer's data submitted by the contractor, verifying components are installed correctly against the approved specs, making sure any field adjustments are properly documented.
And this is where the actual testing happens.
Yes, a key element here is functional performance testing, or FPT. This is where commissioning truly shines, I think. It's not just a visual look-see.
Right, the dynamic part you mentioned earlier.
Exactly. This is where systems are dynamically operated and tested under simulated real-world conditions to confirm they meet the OPR.
Like what kind of tests?
Okay, so for an HVAC system, we might simulate a hot summer design day, then a freezing winter night condition. We'd test if the air handling units sequence correctly, if individual zone dampers respond precisely to temperature set points, if the central building management system accurately logs everything and responds correctly to anomalies.
That's air controls.
Deeply checking the controls, and testing if all the interlocks with, say, the fire alarm system function exactly as designed, like shutting down air supply in a fire event. We're looking at things like temperature stratification, making sure air is balanced correctly to each space, controlling humidity precisely.
Wow.
It ensures every component talks to each other as designed, and that the system can handle its full range of operating conditions.
Yeah.
It goes way beyond just powering something on. It verifies the whole integrated system performs its complex choreography perfectly.
That sounds intensive.
Yeah.
And I imagine there's a ton of paperwork.
Oh, managing the documentation during construction is absolutely crucial. Project management in construction discusses things like shop drawing logs to track approvals of the detailed fabrication drawings, and critically, record drawings, which are often called as-builts. These incorporate important final changes and variations that are not shown in the plans based upon what was actually built.
As-builts are key, right, for the future.
Absolutely vital. It ensures the as-built condition is accurately documented. So, when systems need maintenance or upgrades years down the line, the facility managers know precisely what they're dealing with. They're not guessing based on the original design drawings, which might be different from what was actually installed. It avoids costly guesswork and potential mistakes later.
And safety fits in here, too.
It does. CMAA also stresses the importance of the contractor's written safety program and a site-specific safety plan, ideally overseen by a full-time safety representative.
How does safety connect to commissioning?
Well, while it might seem separate from system performance testing, safety is really an integral part of holistic quality management. A safe construction site often correlates directly with higher quality work.
So.
Because a focus on precision, meticulous processes, and adherence to standards, which are all crucial for safety, tends to apply across the board to the quality of the installation itself. Errors born from a sloppy or unsafe work culture can easily translate into operational issues, maybe even safety issues, down the road. It's about building it right and building it safely.
Okay, makes sense. So finally, we reach the post-construction phase.
The handover.
Right, the critical handover point. This is where the building transitions from being a construction site to an operational, living, breathing facility. And commissioning plays a key role here, too. The CM, as CMAA details, coordinates the compilation, organization, and indexing of all the operational materials, maintenance manuals, operating procedures, the final verified as-built documentation, commissioning reports, and binds them into organized sets for the owner's team.
Manuals and stuff. Yes, and these materials are absolutely crucial for the long-term, efficient performance of the building. Without them, even a perfectly commissioned building can quickly start to underperform because the operators don't know how to properly run or maintain its complex systems.
That seems obvious, but probably gets overlooked sometimes.
It can, absolutely. And it extends to other practical elements too, like warranties and training. These are critical for long-term success. The CM is responsible for coordinating all the requirements for spare parts and warranties, making sure the owner has what they need for the future.
And training the owner's staff.
Yes. Crucially important. The CM assists in securing all permits for occupancy and assists with training of the owner's personnel for the move-in startup activities. This comprehensive handover ensures the building is physically ready, legally compliant, and that the owner's staff are fully prepared and competent to operate and maintain its systems properly.
Like passing the baton smoothly.
Exactly. Ensuring the new runners, the facility team, are fully capable of carrying on the race and keeping the building performing at its peak.
Okay, That was a comprehensive walkthrough of the process. Which brings us back to the big question. After all this meticulous planning, verification, documentation, does building commissioning actually work? Does this elaborate, multi-phased process truly pay off? Or is it just, another layer of bureaucracy in an already complex project?
It absolutely does work. The evidence strongly suggests it more than pays for itself, often many times over.
Ah.
One of the biggest benefits is that early detection piece we talked about and the massive financial savings that results.
Right, finding problems early.
Yeah. The BIM handbook highlights emissions pre-construction discovery as a key benefit when you combine BIM and commissioning. And it directly translates, they say, to saving owners millions in energy costs and rework over the life of the building.
Billions. That's significant.
It really is. Imagine finding a major design flaw like an undersized chiller plant, a misaligned duct system, a controls incompatibility, finding that in a digital model review or during early functional testing, rather than after the walls are up, concrete's poured, and the system's supposedly operational.
Yeah, the cost difference must be huge.
It's exponential. Fixing an error on a computer screen versus tearing down and rebuilding a physical system. There's no comparison. It's about preventing those costly problems that lead straight back to that nightmare scenario you described at the start.
And that ties directly into avoiding cost overruns, which is a major project management goal.
Absolutely. The Project Management Institute emphasizes the PM's role in maintaining awareness of when potential issues, delays, and cost overruns enter the project, and protecting the team's production capability.
And commissioning helps with that awareness.
It's an indispensable tool for it. By identifying problems when they are easiest and cheapest to fix, whether in design reviews or during early construction testing, it actively safeguards the project budget and schedule. It prevents those painful surprises that can derail everything. It means fewer change orders, less finger pointing and potential litigation, and generally a smoother path to project completion.
Are there examples of the financial returns?
Yes, for sure. Sustainable construction, green building design and delivery gives a compelling high-performance case study. It shows significant avoided emissions and annual benefit. For instance, they calculated nearly $2,000 annually for a specific NREL prototype building just from avoided SO2, NOx, and CO2 emissions compared to a standard baseline building.
Just from avoided emissions.
Yeah, which often correlates with energy savings too. It demonstrates the tangible, quantifiable benefits of optimized performance that commissioning helps to lock in. It's not just about avoiding problems. It's about actively achieving superior environmental and financial outcomes over the building's entire operational life. Real savings hitting the owner's bottom line year after year.
Okay, so clear financial benefits. What about the actual energy performance itself?
Commissioning drives enhanced measurable energy performance directly. Think about the building envelope. The Builder's Guide to Hot, Dry, and Mixed Dry Climates details factors like air leakage, mentioning things like sealing gypsum board to the slab and frame using an airtight drywall approach.
Those little details matter for airtightness.
They matter hugely. Commissioning actively verifies these details during construction and through testing, like blower door tests. Ensuring the building envelope is as airtight as designed is absolutely critical for minimizing unwanted heat gain or loss. Less leakage means you HVAC systems don't have to work nearly as hard, saving significant energy.
Like plugging the leaks in the bucket.
Exactly. And that detailed focus extends right into the heart of the building's comfort systems, the mechanicals.
The HVAC and plumbing?
Right. The same source emphasizes the importance of mechanicals, electrical plumbing in overall energy performance. And another source, Fundamentals of Residential Construction, describes complex systems like hydronic heating systems and radiant hydronic system heater and controls that need precise calibration for efficiency.
So commissioning tunes these systems.
Precisely. It ensures these complex systems, from high-efficiency boilers and chillers to sophisticated VAV controls or radiant floor loops, are correctly installed, meticulously balanced, and finely tuned to deliver optimal energy performance, not just minimum functionality. This directly slashes operational costs, reduces the carbon footprint, and ensures consistent thermal comfort for occupants. It's the precision engineering, verified, that moves a building from just existing to truly thriving efficiently.
And it's not just about the building's costs or footprint, right? It's also about the people inside.
Profoundly about the people inside. Construction Management Jumpstart explicitly defines green building, in part as maximizing occupant health and productivity.
And commissioning helps with that.
Directly. A well-commissioned building provides a more comfortable, healthier, and safer environment. Just think about it. A commissioned building is far less likely to have those persistent issues like wildly uneven temperatures, annoying drafts, poor indoor air quality due to ventilation problems, or malfunctioning lighting systems.
Fewer complaints.
Way fewer complaints. When a building works properly, occupants are more comfortable, they're less distracted by environmental annoyances, and research shows they are generally more productive and healthier. It's a direct link between verified building performance and human performance.
That makes a lot of sense. And I guess it helps with durability, too. Fewer breakdowns.
Definitely. That leads to another critical benefit: long-term durability and significantly reduced rework or callbacks, which ties back to those ongoing costs again.
How does commissioning improve durability?
By ensuring systems are installed correctly and functioning properly from the outset, through those meticulous checks and functional testing, commissioning minimizes premature wear and tear on expensive components. Think about a pump that's constantly fighting against an unbalanced system. It's going to fail much sooner.
Right.
Commissioning catches and corrects those issues. It drastically reduces those frustrating and costly contractor callbacks, which CMAA mentions, that eat into maintenance budgets, disrupt building operations, and drive facility managers crazy. Getting it right the first time through commissioning saves money, time, and headaches for years, even decades. It's a direct investment in the building's future resilience and longevity.
And finally, there's maybe a less tangible benefit.
Yes, but incredibly valuable: stakeholder confidence, particularly the owner's confidence.
How so?
When an owner invests in the rigorous process of commissioning, they gain invaluable confidence that their significant financial investment, often millions, even billions of dollars, will actually perform as promised. They know that the building they envisioned, the performance targets they set way back in the OPR, is the building they actually received.
Peace of mind.
Exactly. Peace of mind that it's a high-performance asset delivering on its promises of efficiency, comfort, and longevity. This leads to far greater owner satisfaction, often improved tenant retention because the building works well, and ultimately enhanced long-term value and reputation for everyone involved in the project. It replaces that nagging doubt: will this thing actually work right? With certainty.
Okay, so we've really covered a lot of ground. We've journeyed from the meticulous naval traditions of Isambard Kingdom Brunel all the way to the complex integrated systems of modern buildings. And we've unpacked how building commissioning is this systematic quality assurance process. It ensures a building's intricate systems meet the owner's performance requirements throughout its entire life cycle.
Right, bridging that gap.
It's about going far beyond just the aesthetics, isn't it? It's about guaranteeing functionality, efficiency, occupant comfort, and long-term value, directly addressing that age-old problem of design intent versus actual performance.
Yeah.
It really feels like the industry's answer to preventing that nightmare scenario from becoming your reality.
Well said. And this deep dive hopefully has shown you, the listener, that investing in commissioning isn't just an expense, it's an investment. It means mitigating significant financial and operational risks up front. It means ensuring optimal energy efficiency and sustainability, enhancing occupant health and productivity, and ultimately delivering on the promise of a truly high-performance building. It's a proactive, intelligent investment that safeguards your asset and contributes to the long-term value of our built environment, making sure it performs not just adequately, but optimally.
So as we wrap up this deep dive, here's a provocative thought for you to maybe ponder. If the purpose of technology, as the existential pleasures of engineering suggests, is one of the types of activities in which people engage because they choose to do so.
Interesting quote.
Yeah, and then how much responsibility do we as a society have to ensure that the incredibly complex systems we choose to build for our living and working spaces are not just constructed, but truly performed to their fullest potential? What stands out to you about how this systematic approach, like commissioning, could transform the built environment, making it not just functional, but genuinely aligned with our choices towards long-term value, sustainability, and ultimately human well-being?